Yes. In today's class, we are going to discuss about transformation in computer graphics. Yes, in previous class, we told that what I called as a transformation. We revise first, then we go to our new topics today. Okay. So what I call as a transformation? Transformation is nothing but we call as some changes in some kind of orientation to the objects, images, or you are changing the size of an object, or you are moving an object from one position to another position. So that we call as a transformation. So generally, this transformation contains different types of 2D transformation. So what are the basic transformation I say means translation, scaling, and then rotation. These are the main three basic transformations in 2 dimension. Whereas additional transformation we are saying means we are having reflection and then sharing. So these are we call as an additional transformation. So let me see first what we call as an transformation. So transformation are used to position objects, to shape object, to change viewing positions. In simple words, transformation is used for modeling and then viewing. So what do you call as a 2D transformation? So that we want to know first. 2D transformation is nothing but when the transformation takes place on a 2D plane, that we call as what? 2D transformation. So 2D means what? 2-dimensional. It deals with x-axis and then y-axis. So these are the applications where we are applying the transformations. So while I'm saying the applications, this computer graphics, that is 2D transformation, is used in entertainment, games, computer-aided design industries, and also it is continuing area of research in scientific visualization. So these are the different applications we are applying the computer graphics. So first we see what we call as a translation. So generally, translation, while saying the translation, see this first you are going to the theoretical aspects. First we see the diagrammatic representation, then we go with the theoretical aspects. Let me see this, consider this a diagram. In this, we are having two endpoints. There is a x and y. So in that, I'm giving p of x comma y. So that we consider an original position. Here, your object is placed here means after the translation. So what will occur means the what type of transformation it will occur means this, that is this object in this position of an object that can be translated to a new position p dash of x dash comma y dash. So how we are going to move this object from one position to another position means based upon this translation transformation. For that we are using tx and ty. So tx and ty is nothing but we call as a simply say it as a translation distances. So while I saying translation, now come to this point, it moves an object to a different position on the screen. Whatever display screen it is, you are seeing an object that will be moved from one position to another position is called as a translation. So what you are doing in this means you are translator or point in 2D by adding the translation distances tx and ty to the original coordinate x and y. So for your what purpose means now to get the new coordinate x dash comma y dash. Here I am giving the equation x dash equal to how you are calculating the x dash is nothing but simply you are adding the original coordinates plus translation distance tx, x plus tx. Y dash you are saying means y plus ty. So here the new question, that is p dash equation is p dash equal to p plus t. So next, so what is the next type of transformation is nothing but scaling. So what is the purpose of the scaling is nothing but to change the size of an object. See this diagram. Here I'm giving one first image. Is consider this first image. There we given something A, B, C, D. That and all points we are given. For that we are mapping the diagram image. After this, we are giving the second image, second diagram. More. In that you see we are giving A dash, B dash, C dash, and D dash. What will happen here? The size of the original object is changed to a new different size. So that is what scaling transformation will do to change the size of an object. It also either expand or compress the dimensions of the objects. Whatever dimensions we are giving, that also we can compress or expand. In scaling, how this scaling can be achieved means scaling can be achieved by multiplying the original coordinates of the object with the scaling factor. It is similar to the translation. There we are giving the adding the translation distances to the original coordinates. Now, same like that. In here, in order to add that, we are giving the multiplication process. X dash equal to x into sx. Then y dash equal to y into sy. So P dash, that is new question is nothing but S into P, that is scaling factor into P, where what equal to X and Y is nothing but original coordinates and Sx and Sy is nothing but scaling factors. Next one. So next type of rotation is rotation. While I am saying the rotation, generally what we call as rotation is nothing but rotation we call as simply we say it as you are not to rotate the object. So that we consider as what rotation. So the same thing we are going to do here. So rotate the object at a particular angle theta from its origin. See this diagram. So here I'm giving a radius or there again giving two radius. In that where is our original point position is there in this image. This is one p of x comma y. So that is our original coordinate position. So for that we are applying the theta, angle theta. Using that angle theta, we are going to rotate the object to a new location. Okay. So how it means point P of x comma y is located at the angle pi. Okay. In the horizontal x-axis. That is what given here. Horizontal x coordinate with the distance r from its origin. So what you are doing after rotating it to a new location, that is P dash of x dash comma y dash, you will get a new point P dash of x dash comma y dash. This is what rotation will do. So for this same like the translation scaling, here also we are having some kind of equations. See these equations where P of x comma y can be expressed as x equal to r cos pi and y equal to r sin pi. For this one we can say in equation 1 and equation 2. So P dash, similarly P dash of x dash comma y dash is also represented as x dash equal to r cos of pi plus theta. So if you are multiplying this r cos pi into r cos theta minus r sin pi into sin theta, that you can say in equation 3, and same like that y dash equal to r sin of this one. Multiplying this after r cos pi sin theta plus r sin pi cos theta, you can say in equation 4. Here sign only changed, the plus and minus only changed. Substituting all this 1, 2, 3 and 4 respectively, what we'll get means we will get x dash equal to x cos theta minus y sin theta, and y dash equal to x sin theta plus y cos theta. This is our final x dash and y dash equation. So why you are applying this cos theta and sin theta here? Any guesses? Because we are applying the what? We are applying angles theta in algebraic geometric mathematical calculation. We have seen this cos theta and sin theta. For that we are using sin theta 90 degree, 45 degree, cos theta 90. Like that we are also applying here cos theta and sin theta. For any angle theta, we are applying the degree 90 degree or either 60 degree or 180 degree or 360 degree. For this we are applying the cos theta and sin theta. So what is our last equation? Final equation is P dash equal to P into R. So apart from this basic transformation, that is first type scaling, rotation, and then translation, we are having addition transformation. I mentioned earlier that this reflection and searing, another one is searing. This we consider as an addition transformation. So generally reflection example is best example is mirror. So what you are going to see in a mirror? It will produce the mirror image of an original object. See this diagram, you simply identify what you call as a reflection. See this diagram, we are having original points 1, 2, 3. After you are doing the reflection transformation, what will happen? This will be reflected in the opposite 1 dash, 2 dash, and 3 dash. Same like that you are doing in the second diagram 1, 2, 3. After doing this reflection in this direction, what will happen? 1 dash, 2 dash, and 3 dash. So next one, last type. So shearing. Shearing is our last type in the 2D transformation. Shearing means what? It slants or distorts the shape of an object. What do you call it? Distorts. The slanting, you know that it is slanting means slight alteration in the images. What do you call it? Distorts. Distorts, we simply say that we, for example, we consider one example. You are putting putting in water in the stand in a what do you call as a bucket. In that bucket, you are filling the water. Okay. So that filling after filling the water, you are seeing your face in a standby mode. Okay. After you filling the water in the bucket, you will say there will be a after some kind of timing, giving some kind of timing. What will the water will in the standby mode. So at the time, if you see your face in the water means what will happen? Your face will be as it is. What you are seeing, that face will be same image will be you are reflecting after the you are putting the filling the water in the bucket in a standby mode. You will see the same face. Okay, but whereas if you are seeing your face in the river water, what will happen? So in the river water, if you are seeing your face means what will happen? Ma? It is simply that image will be some kind of distortion or disturbances, maybe some kind of blurring will happen in your faces. So that is what distorts the shape of an object. So see this, consider this original object. If you are doing the searing transformation in the X layering means what will happen means they like this image only will get it. This one, considering this original object in the Y sharing transformation, what will happen means you will get the searing transformation in the Y axis. So once again we'll refresh our today's topic. We have seen the different type of 2D transformation in that we have seen about translation, rotation, scaling, shearing, and then reflection. So what we call as translation, it moves an object to a different position on the screen that we call as translation. For that we are applying translation distances Tx and Ty. You want to move an object from one position to another position means for that we are need the translation distances. So for that we are using the some kind of derivations in that expression. What is the final expression we are getting? The translation is p dash equal to p plus t. In the scaling, what you are going to do means you are going to change the size of an object, or you can also either expand or compress these dimensions of the object. Scaling in this you are having the expression is final expression is p dash equal to s into p. What we call as an s means s is nothing but scaling factors. Rotation. So rotation you are saying means we need the angle theta. So we are applying this rotation in the p of x comma y with the radius r from its origin, and you are applying the angle pi in the horizontal x coordinate. So after rotating it in new location, you will get p dash of x dash comma y dash. So this is what rotation here. So these are the different expressions for a p of x comma y and a p dash of x dash comma y dash. After all this, you are solving this, you will get the x dash equal to x cos theta minus y sin theta, and y dash equal to x sin theta plus y cos theta. So what is our final expression is p dash equal to p into r. Reflection, it produces the mirror image of original objects. This is what given here. Shearing, it slants or distorts the shape of an object. So these are the images, example images. One this is our original object. After shearing transformation is done in a x here, you are getting this. If you are doing in the y axis, you will get this image. So these are the different type of transformations. Thank you, students.